So this is the seventh video about my Cambridge interview, and today we'll focus on problem 95, which I think is a brilliant question. There's a lot of things involved in this question should be considered uh, in your every problem. So, a long slipway inclined and at an angle to the horizontal is fitted with many identical rollers, consecutive ones being a distance d apart. The rollers have horizontal axles and consist of rubber-covered solid steel cylinders, each of mass m and r. Planks of mass m and length much greater than d are released at the top of the slipway. The problem asks us to find the terminal speed v sub max of the planks, and we should ignore air resistance and friction at the pivots of the rollers. So, it is actually false reasoning to suppose that the lost gravitational potential energy of the plank is simply converted into kinetic energy of the rollers. This would lead to the equation of this is the lost potential energy which will tells us that V would equal to this. But the result is wrong because we do not take the fact that speeding up the rollers involves kinetic friction, and consequently there is heat dissipation in the process. So we should focus on how the roller is accelerated, right? So denote by Ft the kinetic frictional force by between a single roller and the plank. So when it touches the roller, T equals 0, and this T equals T. Okay, so I times delta omega equals R times Ft times delta T, and we will be summed to give an equation containing the final angular velocity of the roller. We have this. Left hand side is the total moment, and have this, which equals to V max over R. So what is I? We will calculate that in the last. So on the other hand, during the time interval delta t, the work done against friction. Yes, there are friction because the speed of the roller and m, the plank, is not same, so there will be friction. It has been intensified that it is a rubber covered solid, so it is it has to be some friction. So the heat dissipated Q, delta Q, would be actually LF times delta V. This is the relative displacement of the surface involved, so we times by delta T, this equals to here, where V max is the velocity of the plank, and R times omega T equals the velocity of the roller at time t. So the total dissipated energy would be, to sum the right hand side, we have this. It needs a little trick. We can move all the constants outwards. So the first part will be I times omega max squared. The right hand side, this is just this way. So we have surface. So half of the energy are dissipated by heat. Now we will adjust our final answer to have Vmax equals to this. Alright. This is actually a little bit, I mean, it's not very easy to consider at the first moment. You have to know that anything that covered in rubber will definitely tells you that it will have some friction, or the velocity of the two contact plane remains the same at all times. So this is all for this problem, and it's I think it's a medium difficulty problem. So see you next time.